Welcome back to Beyond the Stars. We always like to push the boundaries of what we know out there in the universe, and so today we're diving deep into a mission that has done exactly that. The Parker Solar Probe, a mission that's gotten closer to the sun than any spacecraft in history.
It's pretty amazing what they've managed to achieve with this mission.
It really is, and it's actually way more difficult than you might initially think. I mean, when we talk about stars being incredibly far away, you kind of forget that we have one right here in our cosmic backyard.
Yeah, you would think just falling right into the sun would be easy, but it turns out it's a massive engineering challenge to actually get there.
It's almost counterintuitive, right?
It is. There are a number of reasons why it's so hard, but first you got to think about the obvious one, the heat. We're talking about a corona with temperatures that can go over 1,000,000 degrees Celsius.
That was actually my next question. How does anything survive those kinds of temperatures?
Right, so it's not just about the heat itself, but also the density of particles. It's kind of like imagine you're in a room with a few sparks flying around. Each spark is incredibly hot on its own, but there are so few of them that you're not likely to actually get burned.
Okay, so you're saying the corona is kind of like that? Super intense heat, but the particles are so spread out that it's not constantly bombarding the probe.
Exactly. And the Parker Solar Probe still has this incredible heat shield. It's made of carbon composite about 11 centimeters thick to protect it from temperatures reaching up to 1,400 degrees Celsius. But the real challenge is getting close to the sun in the first place.
Yeah, that's what fascinates me about this mission. It's not just about withstanding the insane heat, but actually getting there at all. What makes it so difficult to get to the sun?
It all comes down to speed and gravity. You see, the Earth is constantly orbiting the sun at a really incredible speed, about 30 kilometers per second. To actually reach the sun, you have to slow down considerably, which takes a huge amount of energy.
So it's not as simple as just shooting something towards the sun and letting gravity do the rest.
Not even close. If we just launched something directly at the sun, it would basically miss because of the Earth's orbital speed. The Parker Solar Probe actually uses this amazing technique called gravity assists. It uses the gravity of other planets, specifically Venus, to slowly slow down and adjust its trajectory.
So it's kind of like a cosmic slingshot, using Venus's gravity to sort of redirect and slow itself down over multiple flybys.
Yeah, that's a great way to put it. This approach lets the probe counteract that initial speed and get closer to the sun than we ever thought possible. And the closer it gets, the more the sun's gravity takes over, accelerating it to insane speeds.
I read that at its closest approach, the Parker Solar Probe hits a mind-blowing 700,000 kilometers per hour. That's so fast it could circle the entire Earth in just 3.5 minutes.
It's officially the fastest human-made object ever, all because of this carefully planned dance with gravity. But we're not just trying to break speed records or get as close as possible to the sun for no reason. There are much deeper goals behind this mission.
Right. It's about understanding the sun itself, isn't it?
Mhm.
This giant ball of plasma that impacts literally everything in our solar system, including us here on Earth.
Exactly. The sun's something we often take for granted, but it's this dynamic and complex object that really shapes our entire space environment. The more we can learn about it, the better we can understand things like space weather and even how to protect our technology here on Earth.
That makes a lot of sense. So it's not just about satisfying our scientific curiosity. There are real-world applications for this knowledge. What kind of things are we actually learning from the Parker Solar Probe? What have been some of the biggest discoveries so far?
One of the most groundbreaking discoveries has been in understanding the sun's magnetic field. The probe is actually giving us the first direct measurements of the magnetic field, which is really important for understanding how the sun
Like we're
works.
finally getting a clear look at the forces at play inside the sun.
Exactly. And what we're seeing is that the sun's magnetic field is way more dynamic and complex than we originally thought. It's always shifting and changing. And these changes directly impact the solar wind, that constant stream of charged particles that are flowing from the sun.
Yeah, I've heard of the solar wind. How does that affect us here on Earth?
The solar wind can have a huge impact on our planet, especially on our technology.
Hmm.
It can cause interference with satellites, disrupt communication systems, and even cause power outages on the ground.
Wow, that sounds pretty serious.
Yeah, it can be, which is why it's so important to understand the solar wind. And these measurements of the sun's magnetic field from the Parker Solar Probe are helping us do just that. We're seeing how changes in the magnetic field can actually accelerate the solar wind and create what's called space weather.
Space weather. Is that like the weather but in space?
You could say that, just like we have weather patterns on Earth,
Uh,
we have weather patterns in space, and they're driven by the sun. And just like weather on Earth, space weather can be pretty calm or it can get really stormy and disruptive.
So when we hear about solar storms, those are basically extreme space weather events.
Exactly. And those storms can be incredibly powerful. They release huge amounts of energy that can wreak havoc on our technology.
I remember reading about a solar storm back in 1859 that knocked out telegraph systems all over the world. It's crazy to think what something like that could do to our modern technology.
Yeah, that's a scary thought. That's why a mission like the Parker Solar Probe is so vital. The more we learn about the sun and what drives space weather, the better we can prepare ourselves for these events and potentially avoid some major problems.
It's amazing to think that a little spacecraft the size of a car can help us untangle these huge cosmic mysteries.
It's truly remarkable. And the Parker Solar Probe isn't just giving us new insights into the sun's magnetic field and space weather, it's also helping us understand the solar wind itself and how it accelerates to such incredibly high speeds.
Yeah, I was wondering about that. What makes the solar wind move so fast?
Well, that's a question that's puzzled scientists for a long time. But now, thanks to the Parker Solar Probe, we're starting to get some answers. It's actually observing all these turbulent waves and structures within the solar wind. It's almost like ripples and eddies in a stream, and these structures seem to play a big role in accelerating the solar wind away from the sun.
So the solar wind isn't just a smooth, steady flow like we might picture.
Nope. It's much more complex and dynamic than that, full of surprises. The more we study it, the more we realize how much we still don't know.
It sounds like the probe is really challenging our assumptions about the sun and the solar wind and pushing the boundaries of what we thought we knew.
Absolutely. And one of the most interesting things the probe is helping to explain is why the sun's corona, its outermost layer, is so much hotter than the surface.
That's always seemed strange to me. It seems like it should get cooler the farther you get from the sun's core, right?
Right, it's totally counterintuitive. The surface of the sun is about 6,000 degrees Celsius, but the corona can reach millions of degrees. Imagine a campfire where the flames are actually hotter than the burning logs.
Okay, that's a great analogy. So what's going on there? What's making the corona so hot?
That's a question that's baffled scientists for a long time, and we still haven't completely cracked it. But the Parker Solar Probe is giving us some exciting clues. It seems that there are processes happening within the corona itself that are contributing to this intense heat.
So it's not just heat from the sun's core radiating outward. There's something happening within the corona that's generating its own heat.
That seems to be the case. And we think these processes involve the sun's magnetic field, the solar wind, and those turbulent structures we talked about. It's like a giant complex puzzle. And the Parker Solar Probe is helping us piece it all together.
It's incredible that we're just starting to understand these fundamental processes happening right in our own cosmic backyard.
It really is. And keep in mind, the Parker Solar Probe's mission isn't over yet. It's still going strong, and in the next few years, it'll be making even closer approaches to the sun. We're expecting even more groundbreaking discoveries.
So much more to learn. It's like we're entering a whole new era of solar science, all thanks to this little probe that's basically touching the sun.
You said it.
You know, it's amazing when you think about it. We see the sun every single day, but it's only now with missions like the Parker Solar Probe that we're actually starting to understand how incredibly complex and powerful it is.
Yeah, it's definitely a humbling experience. It makes you realize that even in our own solar system, we still have so much to learn. And the Parker Solar Probe is really rewriting the textbooks on our understanding of the star that makes life on Earth possible.
And it's not just about the science either. This mission actually broke a 42-year-old record that was set by the Helios missions. That really shows you how far we've come in our ability to explore space.
Oh, absolutely. The Helios missions were groundbreaking for their time. They got within about 43 million kilometers of the sun's surface, but the Parker Solar Probe has completely shattered that record. It's gotten over 7 times closer.
That's incredible. It's a real testament to human ingenuity and our desire to push the limits of what's possible.
And it's not just about breaking records, right? It's about the amazing scientific discoveries that come with getting that close to the sun. We're gaining insights that we couldn't have even imagined just a few decades ago.
It really makes you wonder, what other mysteries of the universe could we unlock if we could get this close to other stars?
It's a pretty mind-blowing thought, isn't it? The universe is filled with stars, each with its own story to tell. Imagine the possibilities if we could send probes to study them up close, just like we're doing with the sun.
It's hard to even comprehend the vastness of space and all the secrets that are out there waiting to be discovered.
But that sense of wonder and our drive to explore is what keeps us moving forward. It pushes the boundaries of human knowledge further and further. And who knows, maybe someday we'll be having the same conversation about a probe that's touched another star.
Now that would be Truly amazing. But for now, I think we should really appreciate this incredible feat of engineering and scientific exploration that is the Parker Solar Probe. It's completely changed our understanding of the sun, this celestial object that's so essential to life here on Earth.
I completely agree, and I think one of the most important takeaways from all of this is that even the things we think we know really well, like the sun, can still surprise us. There's always more to learn, more to discover, and that's what makes science so exciting.
Well said. So the next time you look up at the sun, take a moment to think about the incredible journey of the Parker Solar Probe. It reminds us that we're living in a time of amazing discoveries, and the universe is filled with wonders just waiting to be explored.
And who knows, maybe someone listening right now will be inspired to become one of the next generation of explorers and push the boundaries of our knowledge even further.
That's a great thought to end on.
Yeah.
So on that note, we're going to wrap up this deep dive into the Parker Solar Probe. We hope you enjoyed the journey as much as we did. If you enjoyed this episode, please like, subscribe, and stay tuned for more cosmic discoveries. We'll see you next time.